Welcome to the channel. Myself, Professor Santosh Shiro, working as Assistant Professor in Department of ECE, CCAB Institute of Engineering and Technology, Vijay. This is a video lecture on MOSFET, that is metal oxide semiconductor field effect transistors. Okay, so let's begin. Let's have introduction first. Okay, MOSFET. A MOSFET is an acronym of a metal oxide semiconductor field effect transistor. It is a semiconductor device that belongs to FET family. It's one of the very popular family member of FET. FET, this MOSFET is a voltage controlled device. What do you mean by that? That is, the variation in the input voltage determines the conductivity of the device. Sometimes this MOSFET is also called as IGFET, that is insulated gate field effect transistors, since gate is insulated from the channel. What is the meaning of this is the gate terminal is insulated from the channel, that is by making use of insulator layer it is being insulated, that is why it is sometimes called as IGFET. Okay, so like other device in this FET family, it is also having three terminals: a source, a drain, and a gate terminal. Okay, now MOSFETs are called as voltage control devices in which the current flowing between the source and drain is proportional to the provided input voltage. Meaning is whatever voltage we give across gate and source is controlling the current that is flowing from source to drain. Okay, so MOSFET is an advanced FET and has been invented or designed to overcome disadvantages of FET. Okay, on the contrary, MOSFET has a smaller value of capacitance and its input impedance is much more higher than that of FET, and it's all because of a small leakage current it is having. Okay, now such a MOSFET finds application widely in switching actions and as well as in the amplification purpose. Okay, now due to its small size, that is we are referring to the physical size of MOSFET, it is very popular and is very commonly used as a transistor in digital circuits. Okay, so let us go further into further details. That is, let's start with the types of MOSFETs. MOSFETs are broadly classified into two categories, that is depletion type MOSFET and next one is enhancement type MOSFET. Okay, so depletion type MOSFET and enhancement type MOSFET, in that again we have two categories, one is N channel and one is P channel. Okay, so what is the basic difference between depletion type and enhancement type MOSFET is, in depletion type channel is already constructed physically, meaning is channel is constructed while constructing the device and the gate to source voltage is needed to switch off the device. Okay, without that we cannot switch off. Now and coming to enhancement type MOSFET, here there is no any pre-constructed channel. The meaning is channel is not pre-constructed in the enhancement type MOSFET. Okay, the here the applied voltage across the gate is needed to create a channel for its conductance. If you want to make enhancement type MOSFET to conduct, then you are required to give the gate to source voltage VGS and you have to enhance the channel that is required for its conduction. That is the basic difference between depletion type and enhancement type MOSFETs. We shall discuss first depletion type and then we shall go for enhancement type in the next video series. Okay, so let us see the construction of depletion type MOSFET. As I already said, in the depletion type also there will be two types, one is N channel and one is P channel. So let us discuss one type of MOSFET, that is N channel MOSFET. So why we call it as N channel is all because of this channel that you are going to see on the screen is, that is N channel. Because of this only this type of MOSFET is called as N channel MOSFET. Okay, so how it is constructed is, you can see over here we take a p-type substrate. Okay, we take a p-type substrate over which in the two parts we'll put in n-type materials. First one is called the bottom layer is called as a source and the upper layer is called as a drain, and in between this source and drain we construct a n channel. Now you can see over here the channel is being constructed physically inside this MOSFET. That is why it is called as depletion type MOSFET. Okay, depletion type MOSFET. Or you can see over here the dark metallic contacts over here. So these are being given in order to connect this MOSFET to the outside world, to the other circuit elements. And here the gate is also constructed, and this gate is also having the metallic contacts. It is being connected to outside world. And very important layer over here is, you can see over here is the shaded part, that is SiO2 layer, that is silicon dioxide layer. Now this silicon dioxide layer is insulating this gate from the channel. You can observe over here there is no any physical contact between this gate as well as this channel. There is no any physical contact. It is being insulated. So in the introduction part I said that IGFET, right? It is insulated gate feed effect transistor. Okay, now what is the need of this SiO2? This SiO2 layer is required to provide a high input impedance for the device, which is very desirable factor. Okay, so that's it. In the next video we can see the working of MOSFET. Thank you.